P-H-Y, Papa, P-H-Y, P-H-Y, Papa, P-H-Y. Physics, physics, physics. Welcome!
Welcome to another Honors Physics Camp lecture. Today we're going to be reviewing graphing skills. Yes, Alex, I guess you could say that graphing is where we draw the line, a trend line that is. So make sure that you take good notes and let's begin. Okay, Alex, the first thing that we need to do is review how to label a graph. That's right, Alex. I'm glad that you remembered from our previous videos that the axes on the graph are labeled based on the dependent and independent variable. Now, remembering the saying dry mix will actually really help you in determining that the dependent variable is placed on the y-axis and that the independent variable is placed on the x-axis. Now, as for the units, it's imperative that we always include the units. Now let's take a look at the graph title, which is written by using the y-axis title versus the x-axis title. Okay, let's take a look at the data set in our lab notebooks so that we can develop a graph. That's right, Alex. We would label it as jump height versus mass of backpack because jump height is on the y-axis and the mass of the backpack is on the x-axis. What else does this graph tell you about the variables measured in this experiment? You're right, Alex. The graph's axis titles tell you that the jump height depends on the mass of your backpack. Now let's take a look at the possible data trends. If you were to plot this data and the data points look like this, what would that mean? Good job, Alex. What if your data points look like this? What would that mean? Great job. What about this last one? That's right, Alex. This would be an example of a no correlation. Okay, now let's try plotting this data and see what the correlation might look like. Good question, Alex. When graphing by paper, it is up to you to decide what value you will use in each square. In other words, what intervals you're going to be going based on. Now, it's important that you set a range based on the data that you have collected. For example, let's take a look at your x-axis. This data consists of the lowest value being 1 and the highest being 8. So what interval would you select to use here? That's right, Alex. You can either use 0.5 or 1 as your interval, which would be very helpful for this data set, since we want to make sure that our data points are easy to read on the graph. And as for the max value, I would make sure that I go over the highest value found in my data set. Yes, Alex, that would work. Okay, what about the y-axis? The lowest is 0.2 and the highest is 0.9. Yes, that's a good interval, Alex, because you would ensure that the data points are spaced out on the graph so that it's easier to read. And as for the max, I would go up to 1 just to make sure that our last data point is not at the edge of the graph. Okay, now let's plot our data, starting with the first point in which x1 is 8 and y1 is 0.2. So 0.1 would be placed here. Next, we have x2 as 5, y2 as 0.28, giving us this point. And then we have x3 as 3, y3 as 0.4. And then we have x4 as 2, y4 0.56, which results in this point. Lastly, we have x5 as 1, y5 as 0.9, which results in this last point. Now, take a look at our graph. What trend do you notice? You got it, Alex. As the mass of the backpack increases, the jump height decreases. Now, what would you say about it being a linear relationship? Do you think it is? Right again, Alex, you start to notice a curve as the mass continues to increase. Now, this type of trend is often referred to as an inversely proportional trend, in which y is inversely proportional to x. Here's my question for you, Alex. Since we're not using a linear trend, how would we determine the y-intercept? We would first linearize the graph by turning all of the x values into 1 over x so that we can now graph it as y versus 1 over x. This would result into the following graph, which gives us a linear trend. Now we can determine the y-intercept by drawing the line that best fits. Yes, Alex, that's right. You can also use your graphing calculator to determine the line that best fits by simply inputting your data into the calculator. Let's try it out together. You must first select Stat, then Edit List, and enter your x values in L1, then the y values in L2. Once complete, you select Stat once again, and now you select Calc, then down to number 4, Linear Regression, and press Enter. You will then press Enter again to calculate the y equals mx plus b equation variables, such as m, which is slope, b, which is the y-intercept. Great idea, Alex. You can also graph this using a computer. Let's try that out. First, let's open up a blank workbook. Now, you're going to type in your x and y values. Now, the x values, we have 8, 5, 3, 2, and 1. The y values are 0.2, 0.28, 0.4, 0.56, and 0.9. Once you have typed in all your values, you are going to highlight or select the data points that you want to actually plot. So you're going to go to Insert, then you're going to search for where it says Scattered Plot or Scattered Chart, which is this one right here. You're going to click on that, and it's going to be the very first one that says scattered, not the ones that have the lines. Okay, we want the scattered plot. So we're going to select that, and it gives you this graph. Now from here, you can modify the chart title and also the y-axis and x-axis title. If you go to where it says Add Chart Element, you can select Axis Titles on the primary horizontal, which would be the x-axis, and then go again and select Primary Vertical. And then you just type in the actual title that you want. Remember, the title should be y versus x. In this case, our y was jump height versus mass of backpack. Okay, that means that we are going to put our jump height on the y-axis, and it was in meters. And then the x-axis had mass of backpack, and this was in kilograms. Now once you are ready to print it, all you have to do is select the graph, and you go to File, Print, and it will show up as a graph that is ready to print. Now, if we wanted to linearize this, we can just copy the data. We're going to copy, paste the data at the bottom. And now we're going to linearize by turning this x into 1 over x, which means that these values that I have on my x-axis will now be 1 over x. So to do that, I'm going to type in equals 1 divided by that value. The next one is equals 1 divided by that value, and so forth. And this will allow us to linearize the graph. Okay. Next, we're going to graph it once again the same way that we did the previous one. So we're going to select the data, Insert, Scattered, and it gives us this graph. Notice, this chart is more of a linear line. Here, we can actually go to where it says Quick Layout and go to Layout number 9 so that it could give us the linear equation. We don't really use the legend, so we can delete that by selecting it. You can delete it. And as far as the equation goes, we simply need the y equals mx plus b as far as for this class. So you can delete the R2 value. The chart title, we're going to relabel it again as jump height versus mass of backpack. And then the title for the y-axis, we're going to once again label as jump height in meters. And now as far as for the x-axis, keep in mind that we are now doing 1
over x. So we would say 1 over the mass of backpack. And this would be in kilograms. Okay? And here would be my graph. Once again, if we wanted to print this graph out, we would just select the graph, go to File, Print, and it would print out that particular graph.
So, Alex, what exactly were you testing out with this data? Um, okay, Alex, I guess that's a good thing that you've taken an interest in science, but I say you focus more of your time on homework and less time on finding ways to get out of it, such as possible zombie threats. Anyways, let's get back to other trends that you might see in graphs. We now understand how to linearize an inversely proportional trend. But what if we saw the following trend in which the data points were curving upward? Yes, that's right, Alex. We call this type of nonlinear trend exponential, in which y is proportional to the square of x. That's right, Alex. We could linearize this graph by developing a y versus x squared graph, in which we would have all squared values of x. Okay, now what about this trend? What do you notice here? Yes, Alex, that's right. It's backwards. So this time around, we would square the y, which is proportional to x. So in this case, we would have to graph y squared versus x to linearize the graph. This concludes our video lecture. Make sure that you took good notes, and that's it. Have a great one.